practice. Okay. So let me open all these tabs and then set a 45-minute timer. See what the 45-minute round. Let's see if for a 45-minute round how much it can do. So yeah, it's good to practice these basics, because if you practice a lot of basics, you'll eventually be able to sort of understand the essence of it, right? Like you can kind of piece together the basics of many different parts, string them together, and solve more complex problems. And then this way, you will not really gain any corporate skills, but then you'll be able to pass interviews, which is, obviously we want to practice this. We can Google everything, right? But we want to practice this so we can get, a job that's very high paying, so we can have lots and lots of money, and then be like the people in the HBO show Succession, where then you can be filthy rich and then insult each other for fun, because then there's kind of nothing else to do because you have too much money. Anyway, that being said, let's start the timer. Okay, so I guess it's a midterm question, and there's these two circuits. Implement this circuit. A and B. Okay. Top level two instantiations of subcircuit A and B. Implement the circuit. Does this does this exist as a module, or okay, I guess this is A, and then this is like B. B was what? X equals Y. So I guess this is gonna be, okay. Assign logic A1, B1, assign A1, B1. It's just gonna be the OR of these two, so this is gonna be the AND of these two. So, and then Z, which is our output, gonna be the XOR of these two. See if this works. Okay, great. Your phone needs to ring from incoming call. Ring. You must do ring or motor, but not both. if it's in vibrate, then turn on the motor. Okay. When the phone needs to ring from an incoming call, okay. If the phone so if the phones vibrate, or if otherwise means the phone is not on vibrate and the phone needs to ring from an incoming call. So both are 0, then the ringer is also 1. If the vibrate mode is 1, then we turn on the motor. I'm wondering if I understood the spec correctly. Heating, cooling. In heating, turn on the heater when it's too cold. Well, for this one I would have used like enum, so like, but that's okay. Heat is 1, cool is 0. Let's see what the other one did. If it rings, otherwise turn on the ringer. So I guess the spec here is saying it wants the ringer basically it wants the motor to be on if both are on, and then it wants the ring to be on if yeah, the spec's pretty terrible. Okay, so basically ring is an enable signal that says you're either ringing or doing the motor. And so if the vibrate's on, then you do the motor, and if there's no vibrate, then you do the ring. All right. So this ringer is just basically ring and not vibrate mode. And then this is just ring and vibrate mode. Okay. The way they worded it is quite ambiguous, because otherwise meaning what? It can mean a lot. Alright, so that's done. So 0 is cool and 1 is heat. So when do I turn on? When either of these are on, also turn on the fan to circulate the air. In addition, the user can also request turn on the fan on 1. Alright, so the fan is probably the most complicated. Right, so either of these requires the fan to be on, or if you manually set the fan to be on. Mode is 1. Assigned to aircon is pop count. Number of ones in input vector. Okay. And I can do this means that there's 1, and then also this means that there's 2. Gate SV, you're given a 4 input vector. Okay. So this is just going to be like out both of I is if in of I right, because then the 0th bit for out both would have 0 ended with 1. Let's check on the previous thing. Still wrong. If it's 3, then it won't go to this, and it won't go to this. I feel like it would have hit oh, pop count is 20, not 10. Alright, in that case, why don't I just do feel like I've done this previously. Count plus equals in of I, and then the sign out is count. Okay, out any is if any of its right neighbor is 1, so this 1, 2 should indicate if in 2 and 1 are 1. Or so so 1 will be if 1 or 0 is 1. So 1 will be so I actually want to do like so the lowest bit will be like 1 or 0, and then like bit 2 will be correspondingly bit 2, and 1. Actually, I don't need to shift it. Since I'm explicitly, like, basically, yeah, referring to this already. Oh, I see, it's a wraparound. So let's test it. So 0 will have 0, and if it's different than 1, 3 would be different than 0, and then like 2 would be different than 3. Isn't this the same as this except 100 bits? So yeah, I mean 99 1 and then right 99 1 and then the neighbor is gonna be 98 0. And then this is the same 99 and then 99. Um, okay, this is the same. Around 15 lines, wow. So 0 chooses A, 1 chooses B, and then bits to 1. So this can go up to 15. There's 8 here. So actually, I kind of want to do something like so this then just concatenates A through I, and then the rest of the bits are just going to be actually ones. And actually, one could do something a little easier, which is just like this. And then so equals m of select I'm curious if this supports 2-dimensional. Nice. So this is a cleaner way to do it. I guess they wanted 15 lines because they wanted you to do a very long case statement. But you could also just replicate it into one bus and then just very easily use the selector like intuitively. This isn't gonna kill out any synthesis or anything because these are just gonna be tied to source, right? So yeah, so this is done. Six to 1 mux. Okay, so this is just a simpler version of that. The 256 4-bit inputs. are packed into this input vector. Select 0 should choose. Okay. So one way you could do it is to say, you know, like select times 3 or something, minus or plus 1 to, you know. I'm wondering if there's a cleaner way to do it, because doing like index math is a very good way to do things incorrectly. So we could just go with the previous strategy of creating 256 banks, and each bank has 4 bits, and then now we transform this into a 2-dimensional packed array, and then we can just probably just do m of select, and that's a little bit easier to read and a little bit easier to write. Okay. Create a half adder. A half adder adds 2 bits, no carry in. It produces a sum and a carry out. So, yeah, I think this is the 3rd time they've asked me to do this question, unless, yeah, no mismatch. Two 3-bit numbers and a carry in and a 3-bit carry. Make 3 instances of it. So you would feed this goes in the 0th index. This the output of the first adder goes in the first one. This is just sum, and this is just like this. I guess sum 4 is a carryout. mismatch. Assume that you have two 8-bit 2's complements. These numbers are added to produce sum. Also compute whether a signed overflow has occurred. What's an overflow look like if flow is like zero, and then the signed overflow is like something like this. I wonder if this C in, like, I expanded these to be explicit, but I wonder if just like different bits works, does. Okay. What do we have? A, B, C in, C out, and sum. Let's solve this one, make sure this is good, and then go ahead and do the next. No mismatches, but there is a mismatch. Okay. K-map to circuit. What is K-map? I haven't done this in a long time. So basically always one, so can't be 0. Oh, they want us to reduce it, which is like, here we just want B to be 0. Here we want CD to be 1, 1, and AB to not equals 0. And then here we just want CD to be 0 and A to be 0. Kind of tedious. Okay. So C is 1 and A comp B is not 0, 1. Or this is going to be D and or CD is 0, yeah, ABCD is 0, 1, 0, 0, and D or CD is 0 and A. So this is like true if well, I guess this is not true if AB equals CD, or if AB equals the bitwise not of CD, so we just not that. If yeah, A comma B is C comma D, or A comma B is equal to the not of this. So is D the LSB or the MSB? This is unclear. This looks like, I'm just gonna okay, so D is least significant, but what is SOP and POS form? Generates a 1 when this appears and a 0 when this appears. Oh, I see. So it's just practice of two different forms. Yeah, I don't think anyone would ever ask that in an interview. Because they generally just want you to solve the problem. So it's just basically like if the binary is going to be 2, 7, or 15. 2, 7, or 15. So I can just say like bin of 2, 0, or bin of all of it, or if bin of 1, 0 equals a 2-bit 1, 0, and then I'm just gonna cheat. And hopefully that just works. Mismatches. So when BC is 1, so 6, what's happening with 6? I see, so it must be this. It must be. We can't just chop off the top 2 bits, because in 6 and pretty much question mark 1, 0 will alias into it. So this is what? This is 3. The input conditions for numbers 3 never occur in the system. So 3 according to this is when CD is 1. Right? Inputs A, B, C, D. So A, B, C, D, C and D is 1, and A and B is 0. So if C and D is 1, A and B is 0, that's 3. So I guess here it implies that 3 is 1. Okay. So I'm kind of curious what other things are just wrong. This is 1011, so 1011 is. Oh, I see. So they do. Fine. So that's how they enforce it. So this is B and C and D plus, this covers both of these. A, B, C, D. I don't remember how to factor out. Is this, but then that's not sum of products, right? I see. So it's just kind of converting this to, like C. Yeah, this is too time consuming. Probably not gonna do this one. This is no. If they ask me, yeah, they're not gonna ask this in an interview because this is like kind of like new grad stuff. All right. Yeah, that's it.